Okay, in this video we continue our trek through electricity and electronics with electric current. Electricity was initially conceived as something like a river, or at one point, a river that flowed. Of course, we've seen in the first video that what's flowing in electricity is electrons. So let's dig into this. The random drift, this is how we ended our last video. The random drift of electrons, it doesn't do any work. Electrons have to be pushed to do work. That's why we have things like batteries. Batteries are pushers. They're pushing electrons around. So the random, just letting electrons do whatever they want, they're not going to do any work. So in order to have electron flow, in order to have electricity, we need a complete path. We need a complete circuit. Circuit, of course, means to go around. So you have to have a closed circuit, which means that you have a source, the pusher, as it were, like a battery. You've got a source, you've got a path, which has to be something like wire, and it has to come back to the source. If it doesn't come back to the source, there's not going to be any electricity. In all the movies, they cut the wires, and that makes what's called an open circuit, because it's not connected. The electricity can't get back to the source. In order to have electricity flow, you need a complete path, a complete circuit, or what we might call a closed circuit. An open circuit is when it doesn't flow back to the source. You cut the wires, and so no electricity is going to flow. The path also needs to be a conductor. So we use copper, for example, as a typical medium for a wire, because copper is a conductor. You can't make a circuit out of rubber. I'm going to hook some rubber up to this battery. That's not going to work, because rubber is not a conductor. Or plastic. I'm going to hook a plastic up to this battery. Not going to work. And so it has to be a conductor that is the circuit, as it were, that carries the electrons from the source back to the source. So there's just some basics about what's needed in order for electricity to take place. Now, let me go ahead and I want to draw a circuit for you. So this is the symbol for a battery. This is one cell of a battery. Now you could multiply this. You could have more than one of these. You could have countless one of these. But the smaller line represents what's called the negative terminal of the battery, and then the longer line represents the positive terminal of the battery. Now, we've got a pusher now. We've got a source of electricity. Batteries usually use chemical reactions in order to create a movement of electrons. We're going to need now a conductor. So we're going to need some kind of a wire that's going to go around a circuit. Now, we can have a switch. So I'm going to go and put a switch here. It's an open circuit until that switch is closed, but of course it's an open circuit because I haven't drawn the rest of the wire. Now I'm going to go ahead and I'm going to put a lamp in here. So here's the symbol, one symbol for a lamp. And you have to have some sort of resistance or else it'll just, that's called a short circuit, where there's no resistance. Like if you were to take a copper wire and put it across the two terminals of your battery, that would not be good. It would be pretty bad. You would see sparking, and it would fry the battery, and maybe cause a fire. You're creating a short circuit when you get electrocuted. Electric sockets in the wall aren't fun at all. When you create a closed circuit, the electricity conducts through you without much resistance, and that's not good. And the circuit breaker goes off, hopefully, and you don't die. So there has to be some sort of resistance in a circuit in order for it to function properly. And then again, it has to be a closed circuit. It has to be a closed loop. It has to go back to the source. Now, currently, this is an open circuit because the switch isn't closed. But if I were to take this switch and I were to make it go down like that and close the circuit, then if we have enough voltage, enough push, then the light will shine bright like a diamond. Anyway, so this is an example of what's called a circuit diagram. Let me go back to my PowerPoint. Here is a better circuit diagram than the one I just drew, a better drawing. But this is a schematic. This is fairly typical. You'll notice that here I have two cells in the battery. And so you can pile these on and on. Notice that the electricity flows from the negative around to the positive. That's the way we say electricity flows. The electrons come out of the negative terminal of the battery. If it's closed, it goes around, lights up the bulb, and then again, a complete closed circuit loop back into the positive. So to recap, what have we said in this video? We have just seen our first circuit diagram. That picture on the previous slide is a circuit diagram. It's a way of drawing, so that we can see it, an electrical system using symbols for things like batteries, switches, and light bulbs, and many other things, as we will see. For the battery symbol, the smaller line represents the negative terminal of the battery. And probably the biggest concept of this video is that electricity flows from the negative terminal around the circuit back to the positive terminal. Electricity flows outside of the battery. Now, inside the battery, it's the opposite. But outside of the battery, electricity flows from the negative terminal around and back to the positive terminal. This has been our first video on electric current.